Hey everyone, welcome back. So we are solving problem based on binary search. So today we are going to solve search in a rotated sorted array. It is also a medium problem from the Leetcode. So in this problem we have given an array and we have given a target. Now you have to find position of the target. Okay, so for this target we have position 4, right? So basically it is a searching problem. If you do a linear search, right? Linear search is basically you will run a loop from left to right and compare every single value with your target. If it is equal, then you can say this is your value. So the time complexity will be big of n because we are iterating over every single element, right? But the real question is that you have to solve this problem in the log n time complexity. If it is asking to solve in the log n time complexity and also we are searching something in the array, that means we are going to use binary search, right? So if you look at it, we have two condition here. We have to search a element and also we have to solve in a log n time complexity. That means we can use binary search. So let me write the code for linear search first. So for linear search, you will run a loop till n. N is our size of the array and compare our value is equals to the target. Then we can return our I because we have to return index or position of that target. So this is our code for the linear search and the time complexity is big of n, space complexity is big of 1. Now we have to solve in log n time complexity. So let's take the example 4 5 6 7 0 1 2 and target is 0. Okay, so the title of this problem is search in rotated sorted array. So we have sorted array. Okay, so we can use binary search only in sorted array, and this is also a rotated means if you look at this example, our 0 1 2 is coming here and our 4 5 6 is coming here. That means these values got shifted to the right and these values comes in front, means they got rotated in this order, but the array is still sorted, right? So 0 1 2 4 5 6 7, so array is still sorted. Now we have to find the target in this array. For this problem we cannot use our binary search as we are using in other problems. In this we have to make some changes according to this problem. Okay, so if you look at it, this is a sorted array, this is also a sorted array. So somehow we have to distinguish in which portion of the array we will be able to get our value, right? So let's apply our binary search. So we have low here, we have high here, so our mid will be 0 plus 6 by 2, it will be 3. So our mid will be at 7, right? Now we have target 0 and we have mid at 7. So these are not equal, right? Now we have to find in which range my target belongs. You can think this is my range, which is sorted element. This is my another range in which I have sorted values and our mid is here. So we have to check is my target value belongs between this range. So initially we first check in which range we are in. So if you compare this low value and the mid value, you can see that we are in the left range because this is sorted, so this should be smaller than this one, right? Let's say if somehow your mid was here and if you compared your low value and the mid value, that means this low value is not less than, so you can say you are in the right portion. So this condition is for finding in which range our mid lies. So if my low is less than equals to the mid, that means we are in this left range, else my mid lies in this range. Okay, now B lies in this range. Okay, now we have to check that my target is in this range or not. Okay, so our first step is find the range in which our mid lies. second step is find if target lies in that range or not. So we have figured out that B lies in this range. Okay, now we have to find that my target is in this range or not. So for this we will write another condition that my target should be greater than low value and my target should be less than mid value, right? So if it is greater than low and less than mid, that means it lies here. If it is lies here, then we can shift my high here, right? Because we don't have any use for this portion, right? So we will shift our high to the left. So our high will move from here to here, but our 0 does not lie in this range. So we can write else condition here. That means it is in the second range. So for the second range, we can move our loop to this position, right? Because we don't have any use for this range. So our low will be shifted here. Now we can find another mid. So mid equals to 4 plus 6 by 2, it will be 5. So our mid will come here. Now again this condition will run. It will check are we in this range or not. Okay, there will be another else condition for checking the another range. Means for this example, we were in this range. If our mid is not in this range, that means it should be in this range. So for this, we will write our else condition. So you have to remember two steps here. You first have to find the range in which our mid lies. Then in that range, you have to find that your target belongs to or not. Okay, so this is our extra condition to distinguish between the different ranges. So for this problem we are going to have two ranges, right? It is already sorted. We just have to distinguish between left and right. So let's write our whole code. Okay, so this is our array 4 5 6 7 0 1 2. Target is 0 and the position is 4. For this problem, target 3, the target 3 does not belong here, so we will return -1. Similarly for this case, here they asked us to solve this problem in log and time complexity. Okay, so let's first declare our size of array. After that we will declare our low and high. Then we will run our loop low less than equals to high. Then we will find our mid, low plus high by 2. Then array of mid equals to the target. Then we can return our mid here. Mid is basically our index. So if we were able to find our target, we can return from here. Now we will distinguish in which portion of the array our mid lies. So if it is in the left portion, we will check my low value should be less than equals to the mid value. That means we are in the left portion, right? If we are in the left portion, now we will check that my target value belongs to that left portion or not. So we will check target greater than equals to the array of low and target less than equals to array of mid. If our target belongs to that left portion, we will move our high to the left, else we will move our low to the right, right? If this condition is true, then we will execute this. If it is false, then we will execute this, right? Similarly, this condition is for that if our mid lies in the left portion. If our mid is not lies in the left portion, then it must be lying in the right portion. So for the right portion, we will again write the condition to check if my target belongs to the right portion, right? So my target will be greater than equals to the mid and target less than equals to the high, right? Because we are checking between the mid and high. Now if my target belongs between mid and high, that means we will move to the right side. Else if it is not belongs to that portion, that means it must be in the left, so we will move to the left. After this, here we will return our -1. If we weren't able to find any position here, so the loop will end and by default it will return -1. Okay, so let's run it. Okay, it should be nums, not ARR. Okay, let's change here ARR. Also let's change here ARR. and here it's ARR. Okay, this high is not a 0, it is n minus 1. So let's submit it. So here you can see our code got accepted. Okay, so this is whole code for this problem. So the extra changes is that you have to distinguish between left portion and right portion. Okay, if you are in left portion, you will be finding your target value in left portion. If you are in right portion, then you will be finding your value in the right portion. If you weren't able to find any value, you will return -1. So the time complexity will be log n and space complexity is wig of 1. So that's it for today. Until then, thank you everyone. Have a nice day.